Everyone, Gurudev NEET Academy welcomes you all. Today we are likely to discuss the topic that is written on the screen, free radical substitution, right? Let us discuss this topic today, free radical substitution. You know, alkane such as methane when reacts with chlorine, rather better to say halogen. It is rather better to say halogen in the presence of UV or sunlight undergo substitution reaction. One of the hydrogen is replaced and monohalogenated product is obtained if the reaction is carried out under the controlled condition, right? Here X is equal to fluoro, chloro, bromo, then iodo. Actually, in halogenation, fluorination is highly exothermic and explosive, and iodination is reversible. That's why fluorination and iodination, for these two reactions we have substitute method as well, but chlorination and bromination can be carried out with these, no problem. Okay. If the reaction is not controlled, all the halogen may be substituted. See, CH4, this time I am taking chlorine in the presence of H nu, right? So what happens? CH3Cl plus HCl. Now this CH3Cl undergo further substitution to give dichloromethane plus HCl, and this dichloromethane further reacts with chlorine to give trichloromethane. It is still have one more hydrogen to be substitute. So chloroform, that is trichloromethane, further reacts with chlorine to give CCl4 plus HCl. This is the substitution when the reaction is under uncontrolled condition, right? So these all being cancelled, you could see the final product as follow: 4Cl2 going to give you CCl4 plus 4HCl. If we want to have monochloro substituted product, then the reaction has to stop. For this purpose, we can use the appropriate amount of chlorine for the substitution reaction. And the mechanism of this reaction is supposed to follow the free radical substitution. Now let us see the mechanism. Mechanism. This reaction supposed to proceed in 3 steps, that is chain initiation. What happens in this step? Actually, if I am taking chlorine, so it is homolytically cleaved in the presence of sunlight to give chlorine free radical. This is the chlorine free radical. And in the second step, that is chain propagation. chain propagation. What happens in this one? CH4 reacts with chlorine to give CH3Cl plus Cl dot, right? Now all the radicals formed during these two processes being terminated in the step third. So that third step is chain termination. The third step is chain termination. So what happens here? Cl gonna combine with the Cl to give Cl2, CH3 dot going to combine with Cl dot to give CH3Cl, and this is also possible, CH3 dot if methyl free radical being formed, so CH3 dot CH3 going to give CH3. Actually in this reaction so many side products being formed. That's why in order to prepare the halo derivative, this is not the appropriate way, but we do carry out the same reaction under the controlled conditions, so we could have the monochloro substituted product, right? And in chain termination, in the third step, suppose we are carrying out the reaction with ethyl, right? Ethane and chlorine, or methane dot going to combine to give you this one, ethane. So on further substitution, it may give you the ethyl free radical. Getting on further substitution, it may give the ethyl free radical, and ethyl free radical undergoes disproportionation. To give CH2 doubly bonded CH2 and CH3. So all these are obtained in the chain termination step. See, this is what loss of, from here if you just remove one hydrogen, so one dot will come here, so this going to combine to give ethene. So here loss of hydrogen means oxidation, and here gain of hydrogen being taking place, so it is what? A reduction. Getting? Now see some of the very important key points regarding the chlorination. First point, in chlorination it is stereo specific. What stereo specific means? More than one products being formed. More than one product are formed. This is what the meaning of stereo specific. The second point, the ease of substitution for different hydrogen is 3 degree hydrogen greater than 2 degree hydrogen greater than 1 degree hydrogen. It means if any alkane carrying all three types of hydrogen. So at least 3 monochloro derivatives will form, because in halogenation, in monohalogenation, how many product will form, that depends on the number of hydrogen atom. So if at least there are 3 types of hydrogen, so at least 3 products will form. We will see the cases later on. The rate of substitution for different hydrogen is, just see, 1:3.8:5. That is this rate being determined from kinetics. It has been determined, right? So this is very key point, because in several reaction you see, suppose you are having CH3 CH2 CH3, suppose you are having propane and you are doing the chlorination, you could see this is 1 degree, this is 1 degree carbon, and the respective hydrogen at 1 degree are 1 degree hydrogen, and respective hydrogen at 2 degree carbon is 2 degree hydrogen, right? So you could see here in this case at least 2 types of hydrogens are there. So definitely in this case we are likely to have 2 products, H nu. What? CH3 CH3, 1 chloropropane. Actually this one will form about 55.89%. You know, we will just calculate how this is coming out to be, because this data help us to calculate the yield. So 2 chloropropane is the major one and coming out to be 55.89%, and another isomer on account of 1 degree hydrogen is 1 chloropropane, and that is coming out to be 44.11%. You know, just to calculate this percentage, this data is very much useful. Let us see how we will able to calculate that 2 chloropropane coming out to be 55.89% in this reaction, right? So for the calculation purpose, to calculate yield, just see 1 chloropropane divided by 2 chloropropane equal to number of 1 degree hydrogen divided by number of 2 degree hydrogen into respective reactivity. In the numerator 1 degree hydrogen, so reactivity of 1 degree hydrogen divided by reactivity of 2 degree hydrogen. So see what it is coming out to be. In propane, how many 1 degree hydrogens are there? Just see here, CH3, CH2, CH3. This one 1 degree, so 3 plus 3 total 6 hydrogens are there. So this is 6 divided by 2. Number of 2 degree hydrogen, just see you are having 2. And the reactivity of 1 degree hydrogen is 1 and 2 degree is 3.8. So it is coming out to be 6 divided by 7.6. Getting? Let us say this is A, this is B. Now you can find out the percentage with these, no problem. Just see A means what? 1 chloropropane. B means what? 2 chloropropane. So, percentage of A is equal to what? A divided by A plus B into 100, which means 6 divided by 6 plus 7.6 into 100. So, that is coming out to be 600 divided by 13.6. If you will calculate it, you will get 44.11%, right? Similarly, percentage of B is equal to what? B divided by A plus B into 100, that is coming out to be 7.6 divided by 13.6, that is 760 divided by 13.6, and this is coming out to be 55.89%. So, in any free radical substitution, by this way you will be able to calculate what percentage of the product, that means isomeric products, being formed. Actually, halogenation, is quite complicated reaction, and complicated I mean to say several byproducts being formed, as the several side reactions are also taking place simultaneously. Getting? But what I talk about chlorination is stereospecific, but bromination is highly selective. Let us see the case of bromination again. Now, bromination. Rate of substitution of different hydrogen is same, 3 degree, 2 degree, 1 degree, right? But rate of substitution of hydrogen in this case is 1:82 is to 1680. Just see, in chlorination what you are having, 1:3.8 is to 5, and see this data, it clearly suggests bromination is much faster than chlorination, right? And it seems to be also, but not, my dear friend. The reactivity order for halogenation is, fluorination, then chlorination, then bromination, then iodination, right? Never think of it, the rate of substitution is this one, but the speed of the reaction follow this order: fluorination greater than chlorination, greater than bromination, greater than iodination. What important in bromination is that it is highly selective, highly stereo selective. If you are not getting the meaning of these two, I will just take with the example. Suppose we are having some concentric circles like this. Getting? We are having some concentric circle, and we are just pointing the arrow to this middle circle. Some of the student like you people will throw the arrow this side, here, somewhere else. Means you are throwing the arrow aiming to this center circle, but you are around as well. But among you, one of the student which is very accurate and very selective, throwing the arrow all the times in this one. So this is, highly selective. It can see only its target here, but this is what is specific. So in this case you get more than one product. See, several circle you aimed, but in this only the center circle being aimed. So this sort of reaction is called highly selective, while this is highly stereo specific. Getting? Actually, this is the meaning of this one. And now when we carry out the bromination, the same you can understood with the ease also. Just see, suppose you are having CH3, CH2, CH3. Now this time you are carrying out bromination in the presence of sunlight, right? Again, two types of hydrogens are there, so definitely we will have two types of product here as well. So CH3, CH3 and bromine will come here, and one more product due to primary hydrogen will be this one. Okay, so definitely this is going to be major and this one is minor. You will say ki sir, you said ki bromination is highly selective, so why you are having another product? We should have only one product. Definitely you are okay. But beta, as I said, organic reaction, several side reactions being taking place at the same time. Okay. So in organic reaction, 100% yield is never possible. This is the fact. 100% yield is never possible. And this is what you need to be noticed for each and every individual organic reactions, because of the same reason several side reactions being taking place at the same time. Okay, now calculate the percentage yield for this one. With best of my knowledge, I hope so, it is coming out to be approximately 97%, and it is approximately, I hope so, 3%, but we will just calculate, right? Now see, this data clearly informs you that bromination is highly selective, because you are getting 97% major product, 97. In the previous case, you are getting about 55-56% only, 55.89, or rather we can say 56%. But see, in this case, we are getting the maximum yield. Why we are getting the maximum yield? Because this reaction is highly selective. That is why the yield being maximized automatically. Now just calculate this one. 1 bromopropane. 1 bromopropane divided by, as we calculated in the previous case, 2 bromopropane, right? What I said? Number of 1 degree hydrogen divided by number of 2 degree hydrogen into reactivity. And what I said, the reactivity in bromination, 1 is to 82 is to 1680, means 1 divided by 82, means 1 divided by 82. Now see, put the numbers. Primary hydrogen is 6, secondary hydrogen is 2 into 1 divided by 82. So you can just little manipulate it. So you will get 3 by 82, that is, let us assume A by B. So what percentage of A is equal to what? A means 3, A plus B means 3 by 82, so it is coming into 100 as well. So it is coming out to be 300 divided by 85. So see what this coming out to be. Let me just calculate for you. (300 divided by 85). It is 3.52%. And what I said, approximately 3%. Getting? What I said, roughly without calculation, I said ki it is coming out to be 3%. It is, if obviously it is 3%, so it will be 97. So similarly, percentage of B is equal to what? 82 divided by 85 into 100, that is 8200 divided by 85. So it is coming out to be 96.48%. See, This much of yield in organic reaction is an excellent yield. Actually, in most of the reaction, maximum yield obtained 60%, 70%, 75%, 80%. In rare of the rarest case, it is we will get the yield about 80% above, 85, 90 and all. But here we are getting almost 96.48% yield. This is the excellent yield as per the organic reactions being concerned. Hardly do we have any reaction in which the yield is coming out to be more than 80%. But this just because of the selective nature, highly selective nature of the bromination, we are getting this much of yield. Getting? Now we will have some problem which is given in NCERT as well in several side book also. Suppose you are having C5H12. This is pentane. So there are three isomeric structure being possible for this one. Normal pentane, that is CH3, CH2, 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 CH3, right? Now isopentane, CH, CH2, CH3. Now one more possibility is there, neopentane. As I said you, during the monochlorohalogenation, how many product will form, that depends on the number of hydrogen atom present. So see the first one. In first one you are having 2 degree hydrogen and 1 degree hydrogen only. So you will expect at least 2 product in the first one, at least. But maximum product you can obtain in the first one, that is normal pentane, is 3. How? Just see. By the substitution of this hydrogen you can have one product. By the substitution of this hydrogen you can have one more product, and by the substitution of this hydrogen you can have one more product. So total 3 monochloro derivative will obtained in this one. I am writing all 3: CH3, CH2, 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 Cl. 1, 2, 3, 4, 5, oh, it's 6. One carbon being excess. Okay. So this is the first 1, 2, 3, 4, 5. Okay. Now this is the second product that you are having, CH3, CH2, CH, CH2 and CH3. Now this time Cl here, plus one more, CH3, CH, CH2, CH2, CH3 and Cl. If you look at these 3 products, all three being different. This is 1 chloropentane, that is 3 chloropentane, this is 2 chloropentane. But if you look at this product, this one, so this carbon is chiral. So including a stereoisomer, if we look at the product, so total in the first one, that is normal pentane, you will have total 4, including one stereoisomer, because this carbon is chiral. You can see this is methyl here, one hydrogen draw downward, the hydrogen here, chlorine here, and this side propyl. So 4 different substituents being attached to this carbon. So this carbon is the chiral one, and if you draw the mirror image of this one, you will get a non-superimposable for this one. So for this one only you are having one more stereoisomers, rather these are non-stereon isomers. Now see in this one, how many types of hydrogen? You all will say, sir, 3 types. So how many product you will expect? Obviously 3 types, but here you will get 4 product. How? Just see. One by the substitution of this hydrogen. So I am writing also CH, CH3, CH2, CH2, Cl. By the substitution of this hydrogen, you will get one product, right? Now, substitute one hydrogen from here. Substitute one hydrogen from here. So, you will get CH3, CH, CH3, CH, and CH3 and Cl. Now, look this carbon as well. Dear student, look this carbon. Up you are having chlorine, this hydrogen put downward, hydrogen, their methyl and their isopropyl. So, this carbon again become chiral because 4 different substituents being attached to this carbon. So, here in this case you will have one more, but we are not talking about the stereoisomers, just concentrate over the normal product. So, one product, two product on account of this and this hydrogen. So, there is the tertiary hydrogen, just see. So, maximum yield will be there for this product. Third isomer, which is third CH3, CH3, Cl, CH2, CH3. So, this is the third isomer, and if we just consider the product, actually in JEE Advanced the question comes, arrange the different product in order of increasing or decreasing yield. So, you can do that one by calculation. I have suggested you the way how to calculate. I am not going to calculate for all, but I have given you people the way you can just try by your own. Similarly, in the cross aldol product, 4 different alpha beta unsaturated carbonyl compounds are obtained. In JEE Advanced the question comes the correct order of the product. So, by knowing different concepts, you are able to predict ki this one is major, this one is second major, third major and least. So, by gaining the knowledge you will be able to do. At one lecture everything cannot be explained, right? Okay. So, 3 products, one more product is there. Actually substitute this hydrogen or this hydrogen, both on the substitution of both will give the single product. So, I am substituting right from here. So, in this case you will have CH2Cl, CH2C, CH3, H, CH2, CH3. See, if you substitute, listen, if you substitute this hydrogen, that product will form, and you could see that one is again chiral. Just see, dear student, just see, this one is chiral. Here you are having methyl, here you are having ethyl, here you are having hydrogen, here you are having chloromethyl. So, 4 different substituents are there with that carbon. So, here you will have one more stereoisomers. But in JEE and NEET, stereoisomers not being asked, only being asked how many product will form. So, these are the way you will be able to predict how many products will form. Now, see the last one. If you do the monochloro substitution of this one, actually this is the formula of pentane. So, 3 isomeric structures are possible, and this will give you 3 different, this will give you 4 different monochloro substituted product, but this one only, because all the hydrogens are primary, so substitution of either of hydrogen will give you the single chloro product, this one, 1-chloro-2,2-dimethyl propane. If you write the IUPAC name of this one, 1, 2, 3. So, what you will write? 1-chloro-2,2-dimethyl propane. So, this will be the IUPAC name of this product. So, this is give you only one monochloro product. So, the question comes, one question I am just giving you. Question: an unknown hydrocarbon gives only one monochloro derivation I wrote, derivative actually. derivative on monochlorination. Identify the hydrocarbon. Identify the hydrocarbon. Right? Given molar mass of hydrocarbon is 70 gram per mole. This is the only given information. Given molar mass of hydrocarbon is 70 gram per mole. Okay. So that hydrocarbon may be alkane, alkene or alkyne. So let us try first of all for alkane. If that hydrocarbon is alkane, so what the formula of alkane? General formula CnH2n plus 2 is equal to 70. So find out the molar mass of this one, actually given. So you will be able to calculate the number of carbon. Getting? So what you will write here? N into C plus 2n plus 2 into hydrogen is equal to 70, right? Now what's the atomic mass of carbon? 12. 2n plus 2, mark bracket here. What's the atomic mass of hydrogen? 1. So by calculating, you will get n not equal to whole number. Whole number means n will come out to be in between 4 and 5. So that is not, this information gives ki that is not alkane. So now move for alkene. Alkene, what formula of alkene? Cn H2n is equal to 70. By the same way, atomic mass of carbon is 12. So this is 12n plus 2n is equal to 70. So in this case, n comes out to be 5. Means the hydrocarbon is what? C5H10. Just see the molar mass, 12 5s are 60 and 10, 70 and 70 was given already. So now the question arises, this is the hydrocarbon. Now we have to look for the structure for which you will get only one product, right? You know, all cycloalkanes are isomeric with alkene. Getting? All cycloalkanes are isomeric with alkane means for C5H10 you can write alkene and as well as cycloalkane, right? But the problem is that on chlorination we are getting the only one monochloro derivative. What does it mean? Ki all hydrogen must be equivalent. So for alkene it is never ever possible. Just see CH2 CH doubly bonded CH CH3 1 2 3 4 5. We can write several alkene, but none of them will have single types of hydrogen. But in cycloalkane you can have CH2 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 CH2. Cyclopentane, just see all hydrogen being secondary hydrogen. So substitution of either of any chlorine hydrogen will give the single monochloro derivative, either of this one, this one, this one, this one or this one, any one. you will get the single monochloro derivative. So the answer for that question is what? Hydrocarbon. Have you identified? Hydrocarbon is what? Cyclopentane. Getting? So the answer for the previous question is cyclopentane, because it is containing all the hydrogens are equivalent, right? Dear student, if you want to learn more such interesting topic in organic chemistry, physical chemistry or inorganic chemistry, please like and share Gurudev NEET Academy channel. As long as I am here, I will continuously provide you some useful and very interesting topics covering all your NEET and JEE topics. Thank you, and thank you for being with us.